One big point I do want to make about the homework, which I wish I kind of would have done this earlier. I said a couple of weeks ago that people are not paying attention when I go over homework, and so I'm going to make sure that people start paying attention when I go over homework. On your chapter 7 test, I think 3 multiple choice were word for word ones that we did as homework. One of them, which was the most this question on the test. One of the questions was literally, what did I say when I was going over the homework? And then there was another question that was, and then on your quiz, it was one thing that I only discussed when I went over the homework. So make sure that you pay attention when I go over homework. The fact that no one noticed that kind of worries me too, but not that. Okay, so most of this one we had already done. One, estimate P, the true proportion of a particular student body who has the flu shot, who the flu shot was successful for with 90% confidence. Was a one sample Z interval, because we don't have to decide between Z and T when we're dealing with proportions. This was that first one that it actually said selected at random. So rewriting random selection really is kind of an overkill and is not necessary. But because it's an answer key, I wanted to have it there. And also, I don't think I'm going to post this answer key, but I'm posting this video. So if you want to like pause through a video to check over yours at any point, that's fine too. So normal, remember you're checking N times P hat. So make sure you got the hat there. Again, this is still part of what was in the video. This is where I talked about yesterday. That's a little bit funny. There are at least 10. Well, this is number for my sample, how many successes in my sample. So technically this is, there are at least 10 students, not just of the population. So technically it's of our sample, which is the ones that were sampled. But I'm probably not going to count off for that. And then had a successful flu shot, had an unsuccessful flu shot, and then don't forget to write so we can use normal approximation. Independent 10% condition. So here, this part is technically talking about the sample, but this part is talking about what? Population. And that one absolutely has to be population, and if it's not, I will count off for that one. I don't think I said this part during class. Who would get the flu shot? Why did I actually add that in that kind of is necessary? And it's, yes, and it's they had a successful flu shot and didn't have a successful flu shot, which means all of these people did what? Had the flu shot. So just saying 8,000 students in a particular student body really probably isn't descriptive enough because of the fact that ones that didn't get the flu shot or couldn't get the flu shot. And I don't have to specifically say they did, but I could think like theoretically like they could potentially are available to. But that one is definitely talking about population. So here I said a lot of these problems are going to give you your what I call X and N. Your X is your number of successes. Your N is your sample size. I've got a nerd stuck in my throat. That hurts really bad. That's why I keep it's like wedged back here. It's really awkward. If I die, just tell somebody that's fine. So it gave us success and N right here. So weird. I would choose to rewrite this as a decimal because when you get to here, that's a whole lot of fractions within fractions, and it looks really weird and it's really messy. So I always choose to turn it to a decimal, but you don't have to. Are these the same numbers y'all got? 0.7248, 0.7752. Okay. Why did I go to 3 decimals for Z again? Just a quick refresh. Because that was on the T sheet, or if you actually look for it in the Z, it's exactly between 2. So conclude we're 90% confident that P, the true proportion of this particular student body who has a flu shot was successful for, like the proportion that the flu shot was successful for of this particular student body falls between 0.7248 and 0.7752. Questions on that one? So that one we've gone most of the way through it. So this one we have not gone through any of it. What is technically our population here, even though I know I don't ask you to write it out? Students what? Oh, I didn't finish typing that one out. This is your population. Ones who took it twice. I didn't finish typing this correctly. What is missing here? That did pay. What did they call it? They called it just coaching course, right? Which was very non-descriptive at all. But I'm just going with wording of the problem. So our population here is technically the ones who took the SAT twice. So make sure that you are including that with every part that we're referencing, that not just that they took the SAT. And then the success would be the ones who did pay for college or for coaching course. Again, I think the wording here was really condensed to where it should say something about like maybe they paid for it after the first one. But again, wording in the problem, I'm just going with exactly the way it is. Method, one sample Z interval for portions. We don't have a decision there. This one just said random sample. So you would actually need to include this part and in parentheses random selection. Again, just saying this, we haven't come across any yet that have the other option, but the parentheses part is saying that it's random what versus random what. This one is random selection versus what? Random assignment. So normal, this one actually gave us both things that we needed there. So just saying again, N times P hat is technically the total number of what? Successes, whereas N times 1 minus P hat is the number of failures. So in this problem, it gave us both of them. Usually we have to find number of failures by doing sample size minus number of successes. And then I'd say there are at least 10 students who took the college SAT college entrance exam twice, who both did pay for college or for coaching courses and did not pay for coaching courses. And don't forget, so we can use normal approximation. So make sure you wrote hat in both of these when you're checking your homework. Independent 10% condition. This part is, y'all are pretty good at this. There are at least 31,600 students who took the SAT twice. Make sure you have twice there. If you missed it before, you probably missed it there too. So with this one, I have to use a rounded number. See if I can come up with this really quick. So with this one, our sample size is really big, so it's not as terrible. I definitely want you going out to 4 decimals here. I'll show you an example that we get to later where if I round to like 3 decimals instead or 2 decimals instead, it dramatically changes our answer. With this exact same answer, if you were to use 2 decimals instead of 4, your upper bound answer is 0.1559 instead of 0.1508, which isn't terribly different because our sample size is so big, but some of them change a whole lot depending on how much you round to. So let's all stick to rounding for P or P hat as 4 decimals. Yes, and that is absolutely fine. And let's everybody get a calculator. We'll just do something run one really quick in the calculator. I want you to go to stat and then over to tests. So we're doing it without just typing it in. All right, so stat tests. I want you to flip through and see if you can figure out which option we should be using. What? So our options are test and interval. We know we're done with interval. Is Z or T? We know we're done with Z. What's another option that you're seeing? 1 or 2. And then what's the other thing? Proportion or not proportion? So we're doing a 1 proportion Z interval. So it's actually what? It's A. So when you go to this one, it asks you for different things. So it asks you for your X. So in this problem, X is what? 427. What is N? 3160. And our confidence level is what, 99%? And so you could do this one, and it actually finds p hat for you while it finds the interval. So this one is slightly more helpful than when we did these with means, because it calculates p hat for you at the same time it calculates your interval. So I said last time I didn't really think it was worth it to do it for means. This one may be a little bit more worth it because it types all the numbers in for you instead of messing up with all the fractions, and it calculates p hat for you. So here I would lean towards using this as opposed to what I did before. Questions with the calculator?
What would you put in for X?
Your number of successes, which is the 427. Okay. Yeah, so X, just like before with when we dealt with binomial, X was number of successes. So that's kind of the way we're looking at it. And then your conclude, we're 99% confident that P, the true portion of students who took the SAT exam twice. Again, I forgot to put who paid. Questions on any of the homework? Yeah.
The second one, if it says in the problem, it's like asking for the proportion of coaching among the students who took it. It's like, is that the same as what we could put here? Or for like our population?
Yeah. So let me make sure I'm looking at the exact same wording that you're looking at so I can answer better. So where it says proportion of coaching among students who retake the SAT. Yes, so you could, yes, because the retake the SAT means they took it twice. It's the success is the ones who did the coaching. So yes, that would be fine to do it wording exactly like that, which I probably would have preferred to do it that way. Any other questions with the homework? Did anybody put anything as the Z other than 2.576 exactly? So I think if you do that one in Z, you get 2.575. Right. So 2.575 is fine because if you go through the process of using the Z, that's what you get. If you use the process of just looking at the bottom of your T table, that's the one you get, and either one of those would be fine. All right. If you'll get out your notes from yesterday.